Let's quickly talk about the process of rationalization. I have a major issue with this word. Just can't pronounce it. For rationalize, making the number rational. Namely, this is the process of taking something that is irrational to make it rational. What are we doing that? This is what is called the process of rationalization. Of course, we don't know, we cannot divide by decimal. We just can't, right? For example, if I have to do the following, if I have to do 1, 2, 3 divided by, let's just say 1, 2, 3 divided by 0.7, I cannot divide by 0.3. What do? I multiply by 10. In other words, I move the decimal place 1, so I need to do 7, 1, 2, 3, 0. So now we have to divide 1230 divided by 7. So I multiply by 10 on top and bottom. So I can move that decimal place, 10 over 10, namely 1. Right? I multiply by 1. Because we just cannot divide by a decimal number. If I have the following, 88, and then I have to multiply by 0.12, that I cannot do. So what we do, we move 1, 2, so I have to put 2 zeros, and then we can do the long division. How many times is that? And then just do the long division. Bottom line, you cannot divide by decimal. Well, that's the problem with rationalization, because if I have the following, if I have 3 divided by the square root of 2, how much is the square root of 2? That would be 1.1, that keeps going. Or a number that we are more familiar with. How much is 3 divided by pi? That would be tough, right? Because 3.14, 15, and keeps going. So I need to keep moving the decimal place, but I never finish. Because by definition, irrational, it keeps going. So if I have 3 divided by the square root of 2, this is an irrational number, so I have to get rid of this irrational number from the denominator. The trade-off is that to move it to the numerator, so we just simply multiply by the same radical, the square root of 2 over 2. And now by magic, my numerator becomes 3 radical 2. This will be radical 4, which is 2. And now we're done. Now we can divide by 2. Right? Before we cannot divide by square root of 2. If I have the following, 4 divided by 7, the square root of 5. 7 is happy. We just simply have to work with the square root of 5. So radical 5 over radical 5. So now that's even worse. So now what do I have? 4 square root of 5. Now I have 7 times radical 5 times radical 5, the square root of 25, which is 5. And 7 times 5, 35, 4 radical 5, and we're done. Very difficult. I have 2 over 5 radical x. That's it. So we multiply by radical x over radical x. Final answer will be 2 radical x, 5 times x. Okay. What happens if my denominator is a binomial? For example, 4 divided by 5 plus square root of 3. As we learned in the past, if I multiply a pair of conjugates, the radicals go away. So the conjugate of 5 plus radical 3 would be 5 minus radical 3, 5 minus radical 3. Now we just do the math. That would be 4 times 5, 20, minus 4 radical 3. What do I have in the denominator? This is period conjugate. This is always A plus B times A. I have A plus B times A minus B. This is A squared minus B squared. Multiplication of conjugates. Difference to square written from left to right instead of right to left. So here will be A squared minus B squared. So the quote unquote A would be 5 and radical 3 here. 5 times 5, 25 minus radical 3 squared, that would be 3. 25 minus 3, 2. If you notice, the 20 is even, the 4 is even, the 22 is even, so we can knock down 2 top and bottom. Or we can factor out 2 from the numerator, that would be 10 minus 2i, oh my God, 2 radical 3, and then of course 22 will be 2 times 11. So 2 over 2 cancel. So the answer is 10 minus 2, I have the space, radical 3 over 11. Okay, let's try 2 more. Oof, okay, this would be, that's okay. Always multiply by the conjugate so we can get rid of those radicals from the denominator. The conjugate is 7 radical 5. Give me 1 second. So let me just have to pause that for a second. So the conjugate would be 7 radical 5 plus 2 radical 11. 7 radical 5 plus 2 radical 11. And now it's just exercise of multiplication. Let's do the denominator first. The denominator will be a squared minus b squared. Here will be 7 radical 5, 2 radical 11. So what we do? We apply the square. 7 times 7, 49 times radical 5 times radical 5, 5 minus 2 squared, 4 times 11. I think that's 245 minus 44. That would be 201. 5 minus 27, 201. I think I did it right. 201. Yeah. So my denominator will be 201. And what do I have in the numerator? We distribute. Will be 2 times 7, that's 14. Radical 3 times radical 5, that will be radical 15. So 14, 15 plus 2 times 2, 4, 3 times 11, 33. So coefficient with coefficient, that will be 4. Radicand with radicand, 33. And we're done. Okay. Sometimes we have a different radical other than the square root. For example, if I need to rationalize the following, 3 over the cube root of x. I need to get rid of the cube root of x. So the idea is to match the index to the exponent. In other words, if I achieve the cube root of x cubed, now my denominator will be x. If I'm able to match the index to the exponent, I'm done. So by how much I need to multiply here? I have x to the 1. I need to get to x to the 3, so I need to multiply by cube root of x squared. Cube root of x squared. So my numerator will be 3 times the cube root of x squared over x, and that's it. Let me try another one. What if I have 2 radical, sorry, uh, 2, whatever, 2. And then I have here 4, the fourth root of x, x to x. Yeah. This just to 5 here. So by how much I need to multiply? Remember, I have the 5 as is. We leave the 2 as is. This is x to the 1. The idea is to get to the fourth root of x to the 4. So the answer will be x. I only have 1. I need 3 more. Okay, so let's just multiply. That will be the fourth root of x cubed. So the answer will be 2 times the fourth root of x cubed over 5x. Deal. Last but not least, if I have 6, the fifth root of x3. And here I have 7. Okay, so if I need x, if I'm the cube, the fifth root, I need x to the 5. I have 3, so we need 2 more. Okay, so the final answer will be the 6 and the 7. Then we need the fifth root of x to the, I have 3, I need 2 more to get to 5. And that will be it. And this is a 5, this is the fifth root over 6x. Thank you.